Good day, civil engineers. This is Group 8 and we're going to discuss about failure, maintenance, and rehabilitation of transportation infrastructure.
Hello sir, hello classmates. This is the report of Group 8. Our topic for today is highway failure and their maintenance. A highway is any public road or other public way on land. A main road, especially one connecting major towns or cities. Did you know that the first highway was constructed on Long Island, New York, in the United States in 1911? Here is the first picture, and this is the second picture of the first highway constructed. So, what is highway pavements? There are two types of highway pavements, the flexible pavements and the rigid pavements. The surface course of a flexible pavement protects the underlying base course from traffic and water while also providing adequate tire friction, generating minimal noise in urban areas and giving suitable light reflectance for nighttime driving. Here are the different parts of the flexible pavement as shown on the screen. The rigid pavements are made of Portland cement concrete. The concrete slab ranges in thickness from 6 to 14 inches. It is laid by a paving machine, often on a supporting layer that prevents the pressure caused by traffic from pumping water and natural formations materials to the surface through joints and cracks. Concrete shrinks as it hardens, and this shrinkage is resisted by friction from underlying layer, causing cracks to appear on concrete. Highway failure. Main causes of pavement failures are rotting due to high variation in ambient temperature. In rainy weather, water can seep through gaps between aggregates and asphalt and act under tire pressure. As a result, the bitumen becomes more brittle, the appearance of cracks and leading consequently to a shorter pavement life. Uncontrolled heavy axle loads. If the highway or the road or the pavement didn't or couldn't handle the truck passing by or the vehicle passing by with carrying heavy loads. Inadequate stability. A role of a sub-base or base course is to transform the wheel load from surface course or wearing course to the subgrade. Therefore, the strength of the sub-base or base course is always higher than the subgrade. That means if the sub-base or the base course doesn't have enough strength, it will cause a damage to the pavement. Loss of binding action. When a wheel load is repeatedly applied on the road surface, it causes internal movement. Internal movement of the particles in the sub-base or base course. This results in relative movement between the surface course and sub-base or base course. In other words, instead of acting as whole, different layers act separately. This is the cause of alligator or map cracking in bituminous surface. Poor design and fabrication. If the design of the pavement or the road is not good or they use a substandard materials and aggregates to make this road, it will cause damage or failures to the pavement. There are four major types of pavement failures. Those are cracking, distortion, disintegration, and skidding hazards. Let's go to cracking. Several different types of cracks can develop in asphalt pavements. The repair depends on the types of crack. Some cracks are load-related and some are attributable to temperature or environment. First is fatigue crack. Fatigue cracking is sometimes called alligator cracking due to the interconnected cracks which resembles an alligator skin. Fatigue cracking is caused by load-related deterioration resulting from a weakened base course or subgrade, too little pavement thickness, overloading, or a combination of these factors. Block cracking is a series of large, typically 1 foot or more, rectangular cracks on an asphalt pavement surface. This type of cracking typically covers large area and may occur in areas where there is no traffic. Block cracking is typically caused by shrinkage of the asphalt pavement due to the temperature cycles. Edge cracking. Edge cracks are longitudinal cracks which develops within 1 or 2 feet of the outer edge of a pavement. These cracks form because of a lack of support at the pavement edge. Longitudinal cracking. Longitudinal cracks occur parallel to the center line of a pavement. These cracks are not load-related. They can be caused by a poorly constructed joint, shrinkage of an asphalt layer, cracks reflecting up of an underlying layer, and longitudinal segregation due to improper pavement operation. Transverse cracking. Transverse cracks occur roughly perpendicular to the center line of the pavement. Also, just like the longitudinal cracking, they are not load-related. They can be caused by shrinkage of an asphalt layer or reflection from an existing cracks or crack. Reflection cracking. Reflection cracks are cracks that form over joints or cracks in a concrete pavement or in an overlay of a deteriorated asphalt pavement. The cracks form because of the movement of the old pavement. Slippage crack. Slippage cracks are crescent-shaped cracks which form because of low-strength asphalt mix or a poor bond between pavement layers. The cracks form due to the force applied by turning or braking motion of vehicles. Second types of pavement failures is distortion. Distortion in an asphalt pavement are caused by instability of an asphalt mix or weakness of a base or subgrade layers. These distresses may include rotting, shoving, depression, swelling, and patch failures. Rotting is a linear, surface depression in the wheel path. Rotting is caused by deformation and consolidation of any of the pavement layers or subgrade. It is caused by insufficient pavement thickness, lack of compaction, and weak asphalt mixture. Shoving. Shoving is the formation of ripples across a pavement. This characteristic shape is why this type of distress is sometimes called washboarding. Shoving occurs at locations having severe horizontal stresses such as intersections. It is typically caused by excess asphalt, too much fine aggregate, rounded aggregate, and asphalt is too soft or weak granular base. Next is depressions. Depressions are also bird baths, are localized low spots in the pavement surface. These flaws can be caused by settlement or other failures in the lower pavement layers or by poor construction techniques. Upheaval is a localized upward movement in the pavement due to swelling of the subgrade. Frost heave is an example of this type of distress. Patch failures. When pavements are patched, some distress may begin to occur. The rate at which a patch deteriorates is influenced by compaction, material selections, and the quality of the surrounding or underlying pavement. Next is disintegration or disintegration. Disintegration is the breakup of a pavement into small pieces that are lost with time and traffic. Raveling and potholes are the most common types of disintegration. Raveling. Raveling is the wearing away of the aggregate particles from asphalt cement. This condition indicates that the asphalt has hardened or that has a poor quality mixture used. Raveling occurs in the presence of traffic. Potholes. Potholes are bowl-shaped holes caused by the localized disintegration of the pavement surface. Potholes typically results from the continued deterioration of another type of distress. Segregation cracks or failed patches may serve as the start of pothole. Poor mixtures and weak spots in the base or subgrade accelerates pothole failures. Last, skidding hazards. Skidding hazards are caused by water on the surface of a pavement, polished aggregates or excess asphalt, or other lubricants on the pavement surface. Maintaining a pavement which allows water to flow of a pavement is a basic consideration. Polish aggregate. Some aggregates are susceptible to wearing to a smooth finish or texture under traffic. These aggregates should not be used in wearing courses. If the aggregate polishes, the surface roughness must be restored. Last is bleeding. A pavement surface can be flushed with asphalt and lose its skid resistance. Bleeding can be caused by too much asphalt in the mix, excess stock or bond coat, or by poor construction of a seal coat.
Good day, civil engineers. This is Alvin H. Oz from BSCE 3B, and our topic is all about failure, maintenance, and rehabilitation of transportation infrastructure. Today, I'll be talking about its maintenance. First, what is maintenance? It is the process of maintaining or preserving someone or something. On the other hand, when we say highway maintenance, it is the preservation and keeping of each type of roadway, roadside, structures and facilities as nearly as possible in its original condition as constructed. We all know that all types of, let's say, infrastructures, they deteriorate with time. That's why effort should be made to maintain its condition. Highway maintenance is also about improving the operation of highway facilities and services to provide satisfactory and safe transportation. Siyempre, pinag-uusapan natin ang transportation here, especially roads and highways, so when a danger is present to traveling public, corrective action should be taken as soon as possible. Now, we have 4 categories of maintenance for transportation infrastructure. First, we have road surface, shoulder and approach, bridge, and traffic services. But I'll be focusing more on road surface and shoulder and approach. But before we proceed, let's talk about the components of roads. We have the center crown, the shoulder, and the ditch. The center crown is a part of roadway shape in which the center of the road, kung hindi nyo napapansin, it is slightly higher than the outer edges of the surface. It is to provide drainage of water from the center of the road surface to the ditches. Next, we have the shoulder. It is a strip of pavement outside an outer lane. So later on, we will talk more about shoulders and its type. It is provided for emergency use by traffic and to protect the pavement edges from traffic damage. And last, we have the ditch. It is a narrow channel dug in the ground, typically used for drainage alongside a road. Maintenance operations for road surfaces. We have 4 different road surfaces here, namely gravel roads, surface treatment, thick asphalt surface, and concrete road. First off, we have the maintenance operations required for gravel roads. We have blading and reshaping or resurfacing. On the left side, we can see a picture of a gravel road. Usually, nakikita natin sila sa rural areas or let's say countryside or provinces. Blading is the maintenance of unpaved roads that involves blading using a motor grader to restore the shape and surface of the road. So blading is the redistribution of surface material over the road surface using a motor grader. It is done to ensure drainage and to maintain the proper slope of the road surface. Reshaping or resurfacing. Problems with gravel road surfaces and shoulder shape can usually be corrected with the motor grader alone. The reshaping of the driving surface and the road shoulder can be done by cutting material with the motor grader and relaying it to the proper shape and ground. So here we have pictures of a roller and a motor grader. So these heavy devices mix gravel, cut into the road surface, evenly spread new road material, and reshape the road surface by moving gravel from the shoulder to the center crown. And to keep the gravel in place, if possible, the use of a roller for compaction will greatly improve the finished surface. This will leave a denser, stronger, smoother surface that will be easier to maintain. Next, we have the maintenance operations required for surface treatment of low-type bituminous pavement. So the maintenance could be patching, seal coating, remixing, and repaving. So patching is the process of filling potholes or excavated areas in the asphalt pavement. We all know what potholes are. These are depressions in a road surface, usually asphalt pavement, where traffic has removed broken pieces of the pavement. And the materials for patching include hot mix asphalt, asphalt emulsion mixes, stockpile patching mixes, and more. We have 2 types of patching, full depth and deep patching. Full depth patching is the removal of the entire pavement surface layer regardless of its thickness over the patching area, while deep patching is the removal of 4 inches or more of the pavement surface course. Yung sa full depth patching, it applies to either asphalt or concrete pavements, pero yung deep patching, it only applies to asphalt pavement. Seal coating. It is the process of applying thin liquid layer added over a paved surface to protect it from damage caused by UV rays, rain and snow, and fluids from vehicles. So yung seal coating, it involves the application of a special mixture to the road that protects the road base from additional wear and tear. So what are the materials used for seal coating? So these are typically bituminous-based products or acrylics. The seal coat is a liquid formulation of one of the following emulsions mixed with water. We have silica sand, polymer additives, and other proprietary fillers and solids. So what are the advantages of using seal coat? When it is applied over existing pavement, seal coating is a really cost-effective way of resurfacing that extends the life of the road by sealing out moisture. It also provides a skid-resistant, anti-glare surface during wet weather, and because it hardens the surface of gravel roads, it provides a dust-free driving surface. Next, we have remixing and repaving. If the repaved method is used, the existing bituminous surface is replasticized, scarified, evenly distributed, and a small amount of new mix is then overlaid by a single machine. The scarification method is carried out to remove old and unnecessary bitumen. And with the remix method, the existing bituminous materials are recycled. Generally, bitumen is recycled through two processes. We have hot and cold in-place recycling techniques. Hot in-place recycling involves softening the surface through heating and then relaying the existing road, while cold in-place recycling involves removing the road to a certain level, pulverizing it, mixing it with an additive, then it is laid, compacted, and resealed. Now, let's proceed to the maintenance operations required for slick asphalt surface. We have retexturing, seal coat, or chip seal. When we say slick asphalt surface, it means that the surface is smooth or slippery or oily. So an example of slick is an asphalt road just after the first rain of the season. So my question dito, does asphalt get slippery? The answer is yes. New asphalt can be slippery. It's due to the fact that it's petroleum based, so when it rains on new asphalt, you can see rainbow swirls develop as it runs off. Surfaces can become slick and dangerous for several reasons. First, they may result from the application of too much bituminous materials. So yun, in extremely hot weather, they bleed, and in wet weather, they become slick. Aggregate particles in the road surface can polish and become smooth over time. So it's because of friction between vehicle, especially yung tires and yung aggregates. So over time, yung aggregates natin ay napapolish. Plus, meron din tayong mga tinatawag na rounded aggregates. So the maintenance operations require is seal coating and retexturing. Pag-usapan natin ng seal coating kanina. Again, it is a bituminous surface treatment, also known as a seal coat or chip seal. It is a thin protective wearing surface that is applied to a pavement or base course. BSCs can provide all of the following: waterproof layer to protect the underlying pavement, increased skid resistance, a filler for existing cracks or raveled surfaces, and an anti-glare surface during wet weather, and increased reflective surface for night driving. And then we have retexturing. This method includes the mechanical reworking of the existing surface to improve its frictional characteristics and therefore the resistance to skidding. Typically involves the removal of material from the road surface. Methods include diamond grooving, shot blasting, bush hammering, and high velocity water blasting. And last, we have the maintenance operations requires for concrete road. We have crack sealing and street sweeping. Concrete roads are considerably less prone to wear and tear defects like rotting, cracking, stripping, loss of texture, and potholes that can occur with flexible pavement surfaces. So yun, in terms of maintenance, yung asphalt paved surfaces tend to require more maintenance than concrete. For example, seal coating should be performed every 3 years. There are well-designed concrete pavements that have required little or no maintenance well beyond their 40-year design lives. So first we have crack sealing. It is a process of placing an adhesive sealant into cracks on the pavement surface, preventing the infiltration of moisture and non-compressible materials into the pavement. And next we have street sweeping. But why street sweeping? Sweeping removes caked mud, abrasives, and other debris from the surface. Regularly cleaning and sealing joints and random cracks keeps them free of water and sediments and protects the subgrade from water intrusion. The next topic is about maintenance operations for shoulder and approach. First, let's define what is shoulder. A highway shoulder is a portion of the road that falls outside the outer lane and is designed for emergency use by traffic. Effort should be made to maintain a smooth transition between the travelway and the shoulder. So we have hard and soft shoulder. A hard shoulder consists of a hardened strip of land. It could be concrete, while a soft shoulder usually consists of gravel or dirt. Shoulders are generally one of the following types: earth and sod shoulders, aggregate surface shoulders, paved shoulders, bituminous or concrete paved shoulders, and concrete paved shoulders constructed with Portland cement concrete. First off, we have earth shoulders. It should be lightly bladed as needed in order to prevent shoulder buildup and to provide a uniform slope sufficient to properly drain the roadway surface. Over time, nagkakaroon ng buildup of soil or earth sa ating shoulders, which then could lead to accidents and inconvenience. So kailangan talagang it should be lightly bladed, and also to avoid the accumulation of water sa road surfaces. Every effort must be made to establish turf and to protect any turf present in order to prevent erosion. Serious and habitual rotting in critical areas should be corrected by the addition of suitable material as soon as practical. So yung fibrous root system ng grass or ng turf binds the soil together, preventing it from being carried off by rains and winds. And also the blades of grass also slows down rainwater, reducing the amount of soil being carried off by the force of the water. In terms of rotting naman, usually di ba pag umuulan, soft yung earth. So pag dumaan yung sasakyan, nagiiwan ng mark, and then mag-stay yun hanggang sa mag-dry na yung soil. So habitual rotting in critical areas should be corrected by the addition of suitable material as soon as practical. Next, we have sod shoulders. So these are earth shoulders on which a solid turf has been established. Normally, they require very little maintenance, and holes, ruts, and settlements should be repaired with sod or stabilized material. Hand labor with shovels is an effective method of smoothing up ruts. Next is aggregate shoulders. Where the aggregate surfacing is light, turf will be established to some extent and should be encouraged to provide additional stability and to provide erosion. Aggregate surface shoulders with an appreciable thickness of aggregate should be bladed periodically to keep the surface flush and level with the edge of the pavement. Blading should be done immediately after a soaking rain to prevent segregation of larger sized aggregate, and the shoulder rolled after blading is complete. So the presence of turf is also needed in aggregate shoulders. That is to provide additional stability and to prevent erosion. And last, we have paved shoulders. Repairs to bituminous or concrete paved shoulders should be in the same manner as for similar roadway surfaces. Since ang ating paved shoulders ay extension lang naman ng ating roadway surfaces, kasi paras ang materials nila, it could be concrete or asphalt. So kung ano yung pag-maintain sa ating roadway surfaces, ay ganun din ang pag-maintain ng ating shoulder. And last, we have the maintenance for drainage. It is the means of removing surplus of water o yung sobrang tubig or liquid waste. First, we have cleaning of ditches, culvert, drop inlets, and catch basins to accommodate free flow of water. So when we say cleaning of culvert means it is a tunnel carrying a stream or open drain under a road. Next, we have the removal of sediments, branches, and other debris gathered at trash racks, culvert and structure entrances, and repair of eroded channels and dikes, and last, riprap and bank protection to prevent recurrence. So that's it. Thank you, everyone.
Good morning. I am Francia Lucido of BSCE 3B, and today I will be discussing about bridge maintenance and traffic services. Bridge maintenance and traffic services are just one of the components of road maintenance. In this diagram, you will see that road maintenance has 6 components: the surface maintenance, roadside and drainage, shoulders and approach, snow and ice control, bridge maintenance, and traffic services. But in this video, we will just tackle the last 2 components since the former has already been discussed by the previous reporter. However, we no longer include snow and ice control since the Philippines has a tropical climate and it is impossible for the country to have snow. How important bridges are. Bridges are an integral feature of a country's infrastructure. It is designed to allow raw materials and finished goods to be transported to factories, warehouses, suppliers, distributors, retailers, and end users. Bridges also facilitate travel so consumers can purchase goods and services in their own communities and beyond. When a bridge closes or suddenly collapses, economic activity slows or grinds to a complete halt. Bridges are vital not just for the transport of commodities, but also for the mobility of people. In this video, you'll notice that the bridge is fractured and is on the verge of collapsing at any moment. Despite this, people continue to attempt to cross that risky bridge until it collapses completely, putting people's lives to death. In order to avert such situation, it is a must to have a regular bridge maintenance. What is bridge maintenance then? Bridge maintenance is the upkeeping of the bridge components in good and serviceable condition so as to ensure a longer life of the bridge as envisaged at the time of its design and construction. So, in bridge maintenance, from the word itself, we are ensuring or upkeeping that the bridge will serve its purpose in a long run. Even if the bridges are well designed and properly constructed, they must be properly monitored and maintained on a regular basis to ensure that they remain in good working order and can last as long as they were intended. There are two distinct types of approach with regards to bridge maintenance. The first one is proactive and the other one is reactive. Fundamentally, proactive maintenance might be described as the opposite of reactive maintenance. So, here is the difference. In reactive maintenance, it operates on a run-to-failure philosophy that minimizes maintenance time and investment. Proactive maintenance, on the other hand, takes steps to anticipate and resolve problems before they occur. The key word in reactive maintenance is run-to-failure, which means maintenance is performed after equipment has broken down. This kind of maintenance is costly because the structure tends to fail unexpectedly, resulting to higher costs for repairs and unplanned downtime. Conversely, proactive or preventive maintenance addresses possible issues before they occur, thus reducing the chances of unexpected equipment failure. It is done to preserve, not simply repair, entire bridges and their components, prevent future deterioration, and sustain or improve their condition. Acting in a preventive manner is proactive and can improve both equipment lifetimes and safety outcomes. Since maintenance is linked with both downtime and expense, it is frequently postponed in the hopes of increasing output and profit. However, this avoidance can be more detrimental in the long run. It's crucial to understand that the cost of performing unplanned maintenance is typically 3 times that of executing planned maintenance. Therefore, a reactive maintenance culture is not an ideal approach. The other technique, which is proactive maintenance, is the best and probably the most cost-effective. Now, let's take a look at the most cost-effective maintenance activities to be adopted in maintaining bridges. The first one is seal or replace leaking joints or eliminate deck joints. This helps minimize deterioration of the superstructure and elements under the joints. Another one is seal deck overlays. This increases the life of the deck by protecting the surface from strong chemicals, weather events, and daily wear. Next, install cathodic protection systems. Cathodic protection or CP is an electrochemical corrosion mitigation technique. When a bridge structure is exposed to salt, it can expect corrosion of the embedded steel during its service life. Cathodic protection has proven itself as the only permanent repair of existing corroded steel reinforced concrete. Another one is employ electrochemical chloride extraction. Electrochemical chloride extraction and desalination removes chloride ions from contaminated concrete and reinstates the passivity of steel reinforcement. Chloride is extracted by creating a temporary electric field between the concrete reinforcement and an anode mesh that is installed externally. During the process, chloride levels are reduced and a high pH environment is created to return the steel reinforcement to a passive condition. In short, employing electrochemical chloride extraction will remove chloride ions that may be present on or around steel components. This helps to protect against corrosion. It is also important to repair concrete. This should take place at the same time as other preventive measures. It protects other bridge elements, including ones made of steel, from damage and corrosion. Frequently paint and treat areas that experience significant wear and tear. This extends the life of the most vulnerable bridge elements. Another thing to do is to regularly paint and coat all steel components. Painting protects bridges from the harmful effects of corrosion and is an important preventive maintenance activity to extend the life of a bridge. This is the best way to prevent corrosion and avoid the deterioration of critical structural steel elements, which is often the most costly and difficult to replace. Next, proactively repair and replace fatigue and fracture-prone details. Treating welds and connective sections can help prevent permanent damage to them and the areas they are connected to. Also, adding redundant system is generally cheaper than replacing the damaged ones. Install scar prevention measures. Scouring is defined as the lowering or loss of top bed soil around the bridge piers, abutments, spurs, and etc. due to the water flow currents. Scouring is always a potential threat to bridge stability, and eventually it can lead to foundation failure. As a response, scar prevention measures must be installed to avoid future and unanticipated failures. Removal of debris is also a must. Trash and other debris may contain chemicals that damage structural elements. It can also block water flow, which may cause significant wear. It is also important to install jackets and other protective systems around the concrete piles. This is the best way to protect against underbridge corrosion and deterioration. Another one is install utility infrastructure protection. Utility components installed under bridges are vulnerable to weather and environmental damage. Installing protective devices can extend their life for decades. So much with that, bridges must also be washed in a regular basis. Cleaning decks, joints, and drains along with all superstructure and substructure elements will slow deterioration of concrete and steel. This sums up the things carried out by experienced personnel during bridge maintenance. Let us now proceed to the next topic, which is the traffic services. Traffic services includes stripping, repair of road signs, maintenance of street lights and signals, as well as coping up with emergencies. What is traffic management and how it is important? Traffic management is the organization, arrangement, guidance, and control of stationary and moving traffic, including vehicles, bicyclists, and pedestrians through a construction zone. Proper traffic management is essential to create safe, orderly, and efficient movement of persons and goods, while also aiming to protect the quality of the local environment. In other words, traffic management refers to a set of actions taken to maintain traffic capacity while also improving the overall security, safety, and reliability of the transportation system. Stripping. It is mentioned earlier that traffic services includes stripping. Strips or road surface markings are used on pavements to provide guidance and information to drivers and pedestrians. Stripping is a continuous function since it is significant in assuring a safe, smooth, and efficient traffic flow. These pavement markings are an effective way of communicating information to drivers on the road. They play essential roles in road safety, directing vehicles for both short and long-range driving activities. Another important traffic service is the repair of road signs. Road signs or traffic signs are signs erected at the side or above the roads to give instruction or provide information to road users. These signs are utilized to facilitate road traffic and increase road safety through the adoption of uniform traffic rules. There are three types of road signs: the regulatory signs, warning signs, and guide or informative signs. Maintenance of traffic signals. Traffic signals offer maximum control at intersections. They relay messages of both what to do and what not to do. The primary function of any traffic signal is to assign right-of-way to conflicting movements of traffic at an intersection. It is also essential to maintain street lights or highway lights. Street lights provide well-lighted streets and neighborhoods. By illuminating roads, highways, parks, and other public spaces, we reduce the risks of accidents such as nighttime crashes, reduces the risk of injuries as well as unwanted crimes. Therefore, traffic signals and streetlights are extremely necessary as these ensure the safety of vehicles and pedestrians. As such, it is essential that signals and lights be maintained to remain functional and efficient at all times. That ends my report on bridge maintenance and traffic services. Thank you for listening.
So hello everyone, my name is Ibrahim Palmeco and my topic is about rehabilitation for our presentation, Highway Maintenance and Rehabilitation. Part 1. Rehabilitation. When the road surface condition becomes poor or defective by worn or damage due to aging, weathering, and the action of road traffic, rehabilitation or resurfacing work is needed to restore the pavement surface to the required level of service. Here, we can see the most common types of damage that affect roads and pavements. We have cracking, potholes, and road rotting or depressions. So, cracks on roads can form due to the forces applied by the turning or braking motion of vehicles. This may also arise from improper mix ratios of the concrete itself. Potholes are holes in the roadway that vary in size and shape. They are caused by the expansion and contraction of groundwater after the water has entered into the ground under the pavement. And rotting can be caused by lack of compaction, insufficient pavement thickness, and weak asphalt mixtures. So one of the methods of rehabilitation is resurfacing. Pavement resurfacing, also known as an overlay asphalt overlay or pavement overlay, is the process of installing a new layer of asphalt over existing pavement, wherein the new layer is generally 1.5 to 2 inches in depth. For Step 1, prep work, sections of the concrete pavement or road are marked with paint in order to identify which parts are to be resurfaced, as well as to indicate the presence of underground utilities or other unknown important facilities. After identifying which parts are to be replaced, the marked sections are then removed to prepare the affected areas for the new concrete. The new concrete is then poured onto the formworks placed by the construction workers, filling the molds entirely. As an optional step, the installation of a subdrain may be included depending on the original subwork. Once the concrete has dried, the surface is then smoothed or flattened by the use of a milling machine or vehicle. Parking restrictions are also placed during this time in order to prevent delays or complications during the milling process. Existing manholes and catch basins are then raised in order to match the same level as the new pavement. An oil product is then applied prior to paving. This oil helps the new asphalt pavement stick to the surface of the new concrete. This also ensures that there is minimal seepage of moisture under the surface of the new pavement. After oiling, a new layer of asphalt is then applied, and sometimes more than one layer of pavement may be required to make the pavement level with the gutter. Finally, any damage caused onto existing properties by the resurfacing process are then repaired. This includes the placement of topsoil and sod, and the new area is cleaned up, removing any signs or barricades used during restoration. Another method of rehabilitation is reconstruction. Pavement reconstruction is the process of installing both the subgrade asphalt layer as well as the top pavement overlay layer. When there's extensive damage or alligator cracks, it is more effective and usually cost-efficient to completely reconstruct than to do an overlay. Basically, reconstruction follows the same steps and principles as resurfacing. The only difference is that in reconstruction, there is the added removal and reinstallation of the subgrade layer. Aside from resurfacing and reconstructing, there are also other important rehabilitation or restoration works that are done during highway maintenance. Among these include Number 1, replacement of defective joints. Number 2, repair of spalled joints. Number 3, substantial pavement work. Number 4, reworking or strengthening of subbase. Number 5, recycling existing materials to improve their structural integrity. Number 6, adding subdrains. Number 7, improving shoulders. And lastly, removing and replacing deteriorated materials. So basically, rehabilitation is just another term for restoration, and in this case, the restoration of roads and pavements that have degraded due to damage. And such damage may be caused by mechanical wear, corrosion, moisture, or even natural calamities such as earthquakes. Next, we have objectives for road rehabilitation. Number 1, to improve the smoothness of the road surface. For number 1, the reason behind this is that smoother roads often last longer, they're safer, they cause less wear on vehicles, and highway maintenance costs are a lot less compared to other roads of different quality. Not to mention, they are also more comfortable to drive in. Number 2, to extend the pavement life. So probably one of the most important aspects of rehabilitation is to promote the effectiveness of roads and pavements. That's why it's very important to maintain the quality of each road so that it can provide years of service during its lifetime, effectively both saving money and time. Then, number 3, to improve the skid resistance of the road. Skid resistance is an important pavement safety evaluation parameter because poor skid resistance can lead to skidding accidents or result in inadequate braking distance during emergency, which often may lead to loss of life, damage to property, or serious injury. For number 4, to construct the sections with poor foundations. Constructed pavement foundation layers often have isolated areas of poor quality that are believed to contribute to localized pavement performance issues. That's why it is important to properly integrate sections with unstable or poor foundation conditions. And lastly, number 5, to improve the drainage facilities. Poor drainage is a traffic safety risk. Water may accumulate on the road like ponds, and accumulated water creates a risk of aquaplaning during rain. A wet surface also reduces friction, which leads to longer braking distances. So, existing drainage networks should be cleaned regularly and extended to receive the maximum flow rate if possible, and proper maintenance of the drains and drainage system can prevent clogging and other unwanted effects. So, efficiency is the quality of being able to do a task successfully without wasting time or energy, while a rating of something is a score or measurement of the quality of an object, idea, or action. Efficiency rating simply refers to the measurement or the quality of work done in order to complete a task. And there are 5 factors that affect the efficiency rating. The first being the rating of sufficiency. The rating of sufficiency is a tool that is used to help determine whether something that is structurally deficient or functionally obsolete should be repaired or just replaced. It considers a number of factors such as cost, reliability, and efficiency, and is ultimately the basis in deciding which projects are either continued or terminated. Next is accident data. Accident data or statistics include a record of road crash statistics and can be used to help identify hazardous driving locations. In doing so, distinction is made between accidents based on accident experiences and accidents based on the specific geographic or physical features of the location. Then we have skid tests. The device used in skid tests measures the frictional resistance between a rubber slider mounted on the end of a pendulum arm and the surface to be tested. This provides road engineers with a method of checking the resistance of wet and dry surfaces to slipping and skidding, both in the lab and in situ, helping to prevent unnecessary accidents that may occur due to slippage. And for number 4, maintenance report. A maintenance report is a document that contains specific information about past maintenance actions and their effect on costs, assets, and business performance. In general, maintenance reports are used to track KPIs and performance indicators which are identified as worthy to follow. And lastly, we have public comments and suggestions. A public comment or suggestion is when a person or organization provides written or verbal feedback to a group or agency to share insights on measures in development under consideration, proposed for adoption, or under maintenance. Public opinion plays an important role in the explored impact of general interest on relevant topics and helps contribute to our awareness about the possible misgivings present within society, which very much includes road safety and maintenance. So this ends my discussion on part 1 of rehabilitation. Thank you all for listening.
Good day everyone. Now we will be talking about the pavement rehabilitation, which includes its processes and its techniques. Pavement rehabilitation is defined as the work undertaken to extend the service life of an existing facility. This includes the placement of additional surfacing materials and works that are necessary to return an existing roadway to a condition of structural or functional adequacy. Pavement rehabilitation has 4 processes. First of this is the prioritization of pavements in need of rehabilitation. This incorporates monitoring activities to assess the functional and structural conditions of pavements. Second is the development of feasible rehabilitation strategies. Third is the selection of the most cost-effective rehabilitation strategy, given a set of constraints which may include reduced service life cycle costs, and budgetary constraints. Last is the adequate measurement of performance of the rehabilitated pavements. Pavement rehabilitation also have different techniques. One of these is the overlays, which includes asphalt, concrete, mill and overlay, mill and inlay. Second technique is recycling. First way of this is the cold in-place recycling, and another way is full depth reclamation. The third technique is the pavement reconstruction. Now let's talk about it one by one. Now the first technique is the overlay. It is the placement of a new coarse pavement on the remaining pavement structure. One of these is the asphalt overlay, a paving method of applying a new layer of asphalt to a deteriorating surface, rather than tearing up an old asphalt surface entirely. An asphalt overlay project will use the existing layers as a base for the new asphalt pavement. Another way of overlaying is called concrete overlay. It is considered as concrete cement-based products that go over existing concrete for repair or decorative reasons. A new concrete surface is paved over an existing bituminous pavement, which can be bonded or unbonded. One more way of overlaying is called mill and overlay. It is a street maintenance technique that requires the removal of the top layer of the street by the grinding action of a large milling machine. After the top layer is removed, a new layer of bituminous pavement is put in its place. One last process of overlaying is called mill and inlay. It involves grinding down into upper layer of the existing asphalt in order to remove any cracks, ruts, and imperfections. Then place a new layer of inlay paving on top of the milled surface, which fills any holes and levels it off. Finally, place an asphalt overlay on top to finish the process. Another technique in pavement rehabilitation is called recycling. It is simply defined as the reusing of the existing materials to produce new materials. A lot of us may ask, why use existing materials instead of buying and utilizing new ones? Here are some facts that may answer our questions. Recycling improves serviceability of age-deteriorated pavements, reduces raw material costs, level deformations, and reestablish grounds. It also retains overhead clearances, minimize lane closure time or user delays. Also, recycled pavements can be recycled itself. One way of recycling in pavement rehabilitation is called cold in-place recycling. It is the on-site rehabilitation of asphalt pavements without the application of heat during the recycling. It interrupts the existing crack pattern and produces a crack-free layer for the new wearing courses. Another way is full depth reclamation, a recycling method in which all of the Another way of recycling is called full depth reclamation. It is a method in which all of the asphalt section and a predetermined amount of underlying material are treated to produce a base course. The last technique in pavement rehabilitation is called pavement reconstruction. It is considered as the full reconstruction, which is the excavation of all asphalt pavements, aggregate base, and subgrade soils to a depth that is equal to or greater than the thickness of the new pavement structure being constructed.